Oh my gosh, I think I'm live. I think I'm live now. Oh boy. Okay. It looks like I'm live. Yes. I've been having some real technical challenges today. Streaming professional that I am. Hello YouTubers. Hi everyone. Hello chat. We're doing a live stream. It's been a while since I've done one, and I thought I should probably do one today. So, hello everyone. I think this is my first live stream of the year. We're gonna just get into it. We're gonna do some pairing today. Let me start up these slides here. And as usual, like if you got any questions, of course, put it in the chat. We'll answer your questions. Let's see. Where is Keynote and Keynote View? That is the wrong one. Did I mention I'm having technical difficulties today? Let's try this one. There we go. All right. Thank you, OBS. Okay. Happy Friday, everyone. We did it. It is Friday. It is almost the weekend. Though it's probably the weekend in some time zones. Yes, it has. Let's do this. It's been a minute or two. I haven't streamed in a while. I just like haven't. Rob, yes, yes, I am having. Chad is asking, am I having technical difficulties today? Yes, absolutely. I will repeat it many times. Lots of technical difficulties. By the way, like, if you can't hear me or there's anything weird going on, please say so. Like I said, I haven't streamed in a while. Been a minute. I think I haven't done much stuff because it's just hard. So I don't know, like preparing slides is too much work, so I haven't been doing it. And also I couldn't think of any interesting topics lately, so like I don't know. I just had a hard time thinking of stuff to stream about. So if you have any ideas for stuff to stream about or stuff like low prep plus fun topics, like please tell me. I would really appreciate that. Um, let's see. Today we're gonna chat about ZJIT. Actually, I want to ask. I'm gonna ask the chat. Chat, can you hear me? I feel bad about this today. It's so unprofessional. Um, we're going to. Okay, great. Thank you. We're gonna chat about ZJIT today. It is a new ZJIT is a new JIT compiler. Thank you, Boo Boo. ZJIT is a new JIT compiler that's in C Ruby. We've been working on it here at work, and I'm going to have a guest on to talk about it, and we're going to do some hacking on it. I'm happy to welcome Max Bernstein today. We are going to talk about JITs. Actually, I should say, what is a people ask, what is a JIT compiler? And a JIT compiler is essentially a compiler that generates machine code at runtime. And we're going to chat about these JITs today. We're also going to try implementing an instruction. So we're going to actually hack on ZJIT and do some programming. And then we'll call it a day. So I'm going to bring Max on now, and we're just gonna chat. And also, like, if the levels are weird or anything, please let me know, and I'll try to adjust the levels. Let's see, where is it? No, that's the wrong one. Sorry. Our intro guest. There we go. And Max, hello, Max. You're
Hey,
on.
Aaron.
You're on. Oh wow, is this
I'm
working?
live.
You're live.
Program assemblist. I like it.
I
It's
don't
much better.
when I have guests on, I don't tell them what their title is in advance, so I'm trying to come up with good titles. Um okay, welcome. Please, Max, can you introduce yourself?
Hi, everybody. I'm Max. I just joined Shopify, like 7 months ago now. And before that, I was in grad school, and before that, I was at Facebook, and I've been doing compilers for a bit. When I'm not doing compilers, I'm biking, climbing, reading, baking. I do a lot of baking,
What do you bake?
mostly bread.
Ah, okay. What's your favorite kind of bread?
That's hard. I think it's mood dependent. I
Ah.
some days I'm like I need a focaccia right this second, and other days I want like a Danish rye or something like that.
But if you're bake like, don't you need to let it rise or something? Like you can't just bake it immediately. Yeah,
I have to anticipate my needs several days in advance.
I see. Okay.
No.
Well, so we're bringing you on to talk about ZJIT. How do you like you work on ZJIT
Hmm.
as your job? Yeah.
It is my job.
Okay. And what do you do? What is it that you say you do here?
It's a good movie. I don't do a lot. I just kind of sit there and everyone else does. No. I I'm setting the technical direction right now, which sounds really managementy, but I'm trying to make sure that we have a working compiler this year. That means we run a lot of code, we run it correctly, and hopefully also we run it fast.
Okay. How so I think there's people who are just learning about ZJIT today. What is what is the difference between like hopefully people know about YJIT, which is the existing JIT compiler in C Ruby. What is the difference between ZJIT and YJIT?
So Widget's great. Widget's been around a couple years now, by actually the same people. So all the same people at Shopify who brought you Widget uh, are bringing you ZJIT, plus me, I'm new. Um, And Wygit is this cool thing called basic block versioning, based on Maxime's research from her PhD, where every basic block, which is a chunk of code in a program with no jumps, no ifs, gets types propagated through it, and then those sort of get linked together with different types and split and joined as needed. So you get very good type information for your compiler. And ZJIT is a slightly different approach, which uses more code at once. So instead of one snippet of code, it uses a whole method, and sometimes even multiple methods if we copy callees into callers.
Okay. Thank. I'm turning Max down a little bit. Thank you, folks. Okay. So YJIT, from what I understand, YJIT is extremely lazy. Would you say that's true? Is it lazier than a
Not
normal method-based JIT, or
not in a pejorative sense, in a positive sense. It
yes,
only
yes.
compiles the code that is actually going to be executed. So if a branch never happens, like it's never true, that code is never going to be compiled.
Well,
Whereas ZJIT will compile it just because it's in the function.
so I say like I guess like a JIT compiler is essentially like I like to think of a JIT compiler as like a very very lazy compiler. Like it doesn't compile any code until you actually need it. That's why they call
Yeah.
it just I guess just in time. But like I feel like YJIT is basically taking that laziness to like the next level, like as lazy as you possibly could be. Where you have a
I think
method,
yeah.
like a method-based compiler is like I'm gonna compile this whole method, and why, like an LBBV or lazy basic block versioning thing is like I'm gonna compile part of this method.
Only the paths that are called. It's
Right.
also slightly less lazy in that it might compile something twice if it's called with different types. So if you have a
Ah.
path that goes through the strings and then a path that goes through the same path with ints, just in time is a good friend of ours.
Thank you, chat. Okay, let's see. What else I want to ask you? Let's talk about like the process. So like basically a JIT compiler is taking our code and converting it into like our Ruby code and converting it into machine code. Like what is the process? What is the like high level process for doing that? Like how does that work?
So Ruby code is very expressive. You can do a lot in a very short snippet, and the existing Ruby compiler, as part of yarv, which is yet another, I think, Ruby VM, takes that very expressive Ruby code, which is what you're typing in, it turns it into bytecode, and that's a linear sequence of operations with some control flow, some jumps in it, and that exists already. We take the bytecode, which has some very generic operations like send, method call, and we turn that bytecode into a graph representation.
Mm-hmm.
So instead of having a stack that is used at runtime, we sort of unroll the stack. So we have this instructions directly pointing to other instructions, um, blocks directly pointing to other blocks instead of via offsets, and and then we do some optimizations on that. So we optimize that graph until we're done. And right now, done is just we do a couple things to it. And then we turn it into another graph, which is slightly more linear, called LIR. That's the lower level thing. So we've taken all these high level concepts. Sorry, I'll stay within the box. We've taken these high level IR concepts like send, and we turn them into simple assembly operations and function calls. So this is a portable assembler that works on ARM, it works on x86. I mean, those are the only two platforms, but it could work anywhere. And then we allocate registers, and then we go from there to machine code.
I'm looking forward to the S390X port.
That I'm sure we'll do in 10 years.
So we go from, like, just to kind of recap, we basically go from, like, if we start at the Ruby code, just like your source text file, we go through a compilation phase, and that's where YARV comes in. Basically, we have a compiler that converts your Ruby code into YARV bytecode. That bytecode is essentially straight line, just like straight line bytecode. ZJIT takes the bytecode and converts it back into a graph, like a CFG.
Yes. So CFG different from an AST in that an AST has this nesting structure
Okay.
that is very tree-like. It is a tree, whereas our control flow graph is every operation is spelled out. So blocks are lists of things, but then they jump to other blocks, and within a block, instructions refer to each other by pointer.
Are we able to see, like, we can see the basic blocks, like we can print them out?
Yes.
Okay.
We have, so the ZJIT comes with some nice facilities for debugging. Roberto says we're a bit low on audio throughout.
I don't know how to turn it up, so turn up your
Just
volume.
yell.
Yes, okay.
So ZJIT has some nice facilities for printing. Some of them come from, we ported the assembler from YJIT to ZJIT, so that's some nice infrastructure that we got to use. And then we also, so we can print out the HIR before and after optimization. We can print out the LIR, the low-level IR, and then we can print out the disassembly also using this library called Capstone.
Okay. So we can see the whole thing.
The whole thing, start to
Okay.
finish.
All right. Let's see. What else was I going to ask you? Oh yeah. What can a JIT compiler do that an AOT, like an ahead of time compiler, can't do? Like, what are the differences? Why use a JIT compiler when we could just, like, I don't know, take our LLM, convert Ruby into Rust, and then just compile it?
There's a project at DARPA actually that's doing that. They want to transform all C to Rust in one go using LLMs. It's a very interesting problem. What can a JIT compiler do? So AOT compilers are really good when you have type information available readily.
Mm-hmm.
So in, let's say, C++ or C, you have types annotated in your code. They're required when you, maybe you have auto, but that gets inferred simply. And that's great. You can use those types to do some compilation. And even if you don't get any runtime information, like what functions are called, you can still do a pretty good job. Ruby is different. Even if you have sort of sorbet style type annotations, which a lot of people don't because there's sort of not everybody likes types. The type annotations that you would put, like integer, don't mean a lot to a JIT compiler. So integer is great, but it's a bad example. You can't subclass integer, or you can, but you can't instantiate. But the type annotation is less specific than a JIT would want to use to optimize the code.
Got it.
So the JIT can use stuff like hidden classes or shapes, which I think you and Gemma implemented.
Yes, we did.
And shapes are the actual runtime layout of an instance of a class, which might vary execution to execution, but the JIT knows
how it's actually laid out. Yeah.
How it's laid out only at runtime.
Makes sense. Let's look at, I kind of want to look at some of this stuff. Let's write a program. Look at the YARV instructions, look at the HIR instructions, and then if we can, look at the machine code too.
Let's do it.
Okay. Let's see. How do I do this? Us and desktop. There you are. Hey. Hello. I'm gonna move you close. We're gonna get closer to each other. There.
Let's do it. We need Justin.
Justin, yes, just in time. It's just in
Yeah.
time. Are you in the? You're in here. You can see my screen.
I'm in the teammate.
All right, let's do it. What are we? So what kind of function would be good? Like something with an if statement, I think.
Yeah, let's do a branch on the parameter where if it's less than 0, we...
Is this font big enough for If this is, let me know if I should make it bigger, and I will.
I think that's good.
Okay.
That's big.
Yes, we're gonna keep it big so everyone can read. Okay, so let's do something like if x is less than something.
0.
0. Okay.
I don't know, or not.
No, I don't know.
And then we could do...
Should we add stuff to it, or like have a local y equals?
Yeah.
Yeah?
That's a good idea.
And then
Let's
we'll do
add
like y plus equals 5.
Sure. Plus equals. Okay, sure. That's
And
a
then-
set local, right?
Yeah, and then y plus 50.
Yeah.
Okay, so if we pass a negative number, we're going to add 5. Otherwise, we'll add 7. And then we'll add 50 at the end. And I guess the reason I wanted to do this is if we were going to draw this out, I'm going to do a little screen brush here. If we were to draw this out, we would have how many basic blocks are we going to have here?
At least 4.
1, 2, 3, 4. So like we have a block which is the header, like the header plus I guess the conditional.
Yeah.
Then we have a block that's like the body, these two bodies, and then finally we have a block down here at the end, which is our total, like our ending block. Yeah.
That seems right.
Okay.
Only
So
one way to find out, though.
yes, we gotta actually run it. Let's call foo.
Yeah.
How many times do we need to call it?
The default is 2.
Okay, we'll do it. We'll do. Should we call with a negative number and a positive number, or what do you think?
Yeah. Ooh. Let's actually Let's only do
Positive.
positive.
Okay.
I wonder if it'll do the same thing.
Okay. So an interesting thing about ZJIT is that it will propagate types through the system. Is this going to demonstrate the type propagation for us?
Yes.
Okay. Great. So we can actually see when we print out the HIR, we can actually see types flowing through the system.
Should we do bytecode first?
Yeah, let's look at the bytecode first. So we'll do mini Ruby dump equals insns test.rb, and this is very big, but I will leave it this way. So this is the bytecode. Boy, should I make this smaller? I'm gonna make this smaller.
You should make it a little smaller.
I'm sorry, chat. We're gonna make this a little smaller so we can fit it on the screen. Let's see. Yeah, okay. So here's our bytecode. This is
Wait, scroll down. That's the main.
Yeah, that's the main program. Here, okay, boy, that's a lot of code. Here is our code. So we can see like what is this? Here's the 1, 2, 3 from the code. Here's our set local for y. Here we do a get local for x. This is our parameter, yeah? And then we're saying like, hey, does this thing, we're comparing it with 0 so we can see our like comparison right there, yeah?
Yeah, and all these things implicitly communicate via the stack. So put object puts 1, 2, 3 on the stack, and then set local y takes it off the stack.
So ZJIT is just running through all of these instructions and building a control flow graph out of these. So it's converting it into a graph data structure basically.
And it takes away the stack.
Okay, so let's print out the HIR, right?
Yeah.
How do we do that? ZJIT like that?
My head's in front of it.
Yeah, I'm gonna.
Oh yeah, that's correct. I can see my other.
Let me put this at the top here so that people can see. Let's see. Mini Ruby -ZJIT. Okay, so this let me get out the brush again. This right here enables ZJIT. This prints out the high level instructions. Yeah.
Yeah.
Okay.
Although any ZJIT operation will also turn on ZJIT.
I guess that makes sense. So if we run this, oh my goodness.
So this is the optimized HIR. We can also look at the initial HIR if you want. I don't know what you prefer.
I don't know. Let's look at this. Let's look at this for a second. I guess look at the initial one. So we can see like is the here is one of the get out of the way. Here's one of the basic blocks. Yeah, that's the entry basic
Yes.
block. And we can see the numbers here 1, 2, 3, 0. And then we have this patch point here. What is this for?
So in Ruby, you can do a lot of stuff like you can redefine what less than means on an integer.
Mm-hmm.
So you can, if you redefine integer less than, um, behavior of all Ruby code changes. So there's this thing in the interpreter called a bot check or a basic operation check that checks at runtime if you have redefined integer less than.
Stop.
But we don't want to do the check. We want to be very lazy about it. So we insert this marker which creates no code that if someone does integer less than overwrite integer less than, this code gets stomped on and
Okay.
we go back to the interpreter.
I see. So this is basically like an escape hatch for like
Yes,
if somebody redefines one of these things, we're going to update our machine code here that if this gets executed, it's going to jump back into the interpreter.
that's exactly right.
So essentially, if anybody monkey patches that stuff, they go slow path. So
They go slow path.
yeah. So like, don't do that.
I'm not here to tell you how to write Ruby, but we do have a fast path.
All right. So then we have, let's see, what else we got going on here? So this is okay. Go away. Go away. This is our basic block 0, and we have a jump here to BB2. Yeah.
We do. We also have a jump above it to BB1.
Okay, here we go. So we have essentially like two output, like these form a graph, right? So BB0 can either go to BB1 or it can go to BB2,
Yeah.
and those are our jumps. And here's BB1 and the code for that, all this stuff, and then BB2. Okay, sure, seems good. How do you print out like the pre-optimized thing?
HIR dash init.
Oh, hold on. Let me do this at the top. HAR dash init?
Yeah. So
Like that?
initial. Yeah.
Okay. Oh, wow. That's a lot
So
simpler.
it's very different. It's all the sends. So very textual. Look up the less than
Ah,
thing.
look at that. Okay. So, like, right here, what you're saying, we have essentially a method call, yeah? So none of this is, I see what you're saying. None of this is optimized. This is
Right.
pre-optimizations. Okay. Interesting. Very interesting. Okay. And then how do we see the machine code?
Do you want to see LAR or straight to assembly?
Oh, let's do LIR because I don't know what that looks like.
ZJIT dump LAR.
Okay. Oh, interesting. Okay, so this is so we go from HIR, which is the CFG, to an LIR. LIR is linear.
It's linear. There are
Okay.
jumps within it, but it's more linear.
Okay, I see. Horst says the HIR pretty much looks like a direct translation of the ARV instructions. That's very, like, the simplified one does, for sure.
Kind of. It is a translation still though, because we don't use a stack. We've unrolled the stack, and if you say v0 is this, that's actually not a variable assignment. It is an allocation, and then anything that says v0 is a pointer to it. So
Let's do one more. So one more thing I
yeah,
kind of want to point out is let's see if this is in the init. Yeah, it looks like this is all in uh SSA form, yeah?
yes,
So for those that are unfamiliar, SSA form is essentially like we can have as many variables as we want, but there's only ever one assignment. So a particular variable is only ever assigned once. And we can reuse that, like we can use the variable as many times as we want. We can read from it as many times as we want, but we can only write to it once. And that's what all these V values are, yeah?
yeah. They're
So
they're they're invented names for the outputs of instructions.
so we have, like, for example, v2 here, this nil class. We have a variable v2 that's assigned the value nil, I guess.
Mhm.
And I don't know what we do with that. Like, where is that even used?
I think that's used to zero out the locals and the not zero to nil out the locals
Nil
in the
out the
stack.
locals. Yeah. Okay. Okay. So we have like v4, which is the value 123, and I can see that right here we add v4. So that was our add in the original code. Okay. Cool. And then LIR is, let's look at the LIR again. LIR is, this is what we're going to lower to actual machine code, right?
Yes,
Okay.
this is not the function. This is the entry that the interpreter uses to jump into it. I think if you scroll up a little bit, you'll see the actual function,
Okay.
which
Oh
is
gosh. Oh my
bigger.
gosh. Oh my gosh. Look at that. There's foo. Oh goodness.
So a
Yep.
lot of this is sort of line noise for the stream
Mm-hmm.
purposes, but is very important when you're debugging.
Okay. Yeah. Let's maybe look at that later. Let's look at the actual machine code, and then
Sure.
let's try like hacking on ZJIT. How do we see the machine code?
Uh, Dump disasm.
Disasm. Okay. Oh, neato.
So this also prints out machine code, yes, but also the HIR instruction that generated that.
Ah, okay. So this was the LIR, yeah?
Yes. What is going on here?
A64 reg. I don't know, right?
We're looking at a
Locals.
site. Well, we're looking at a site exit stub. So this happens. This is a site exit if someone smashes integer plus.
Ah.
Scroll up like a lot, I think.
Oh, there's our bop redefined, yeah.
Yeah.
Const value 7. Oh, look at this. Okay, so we can see our patch point. This is our patch point for when somebody monkey patches plus, and we've emitted a bunch of NOP instructions because that's the machine code where we're gonna like write in a jump, possibly.
Yes. Normally we shouldn't have knobs. Normally it'll just jump over the next code.
Oh,
It'll write over the next code, but I don't know. A lot of the time we don't have knobs. It's only if we can't overwrite something for some reason.
I think this might be a, what do you call it, like a unique feature of ARM64. I'm guessing if we look on x86, it will not have all that jazz.
Probably not.
Okay. Let's go look at the code and like add some stuff.
Let's do it.
Okay. Let's see. What do we want to do? We're gonna add an instruction today. We're gonna add class variable get, right?
Yeah.
I think that was the plan, and that is, I think like that. I think that's
Sure.
a class variable get. Let's do foo dot foo. I'm gonna run this because I gotta tell you, I don't actually remember how class variables work.
I just remember being so confused when I started learning Ruby from PHP that all these sigils were different and they meant different things and I didn't know what.
Okay, let's see. Mini Ruby test.rb. Hey, that works. Okay. Yeah, I mean, these are so weird. I personally wouldn't use a class variable like this, but anyway, that's one of the reasons it hasn't been converted to ZJIT yet, is because I would say it's not a particularly popular instruction.
It's not a very classy feature.
No. Oh, I have another question for you. What does Z stand for?
Z stands for Z. No, I don't. It's Z.
That's what I was gonna say.
Yeah. Okay. Thanks, Aaron. Maxime, who started the project, just said, "Oh, we should do probably Z because it's after Y," and everybody went, "Yeah, all right."
But that's not the interesting thing though. The interesting thing is that like she's Canadian but called a ZJIT.
Right. That I don't understand.
Okay.
But I'm not here to. I'm great. If you call it ZJIT, I call it ZJIT.
I think it. I mean, I think it's ZJIT, but the Z is short for Zed, so the full name is Zed. No.
I have no opinion on this matter. I just know that a lot of the people who are not from the US have trouble with ZJIT. They call it ZJIT.
ZJIT. Yeah, I think that's fine. All right, so we got the the heck is it? There's our set class variable. We're not going to do set class variable. We're going to do get class variable today, yeah?
Yes.
Yeah,
Yes.
let's do it. Okay.
Because most of the time, you're not going to be defining a class variable in a method.
No, you're going to be reading. It's going to be read heavy, yeah? So let's, all right, let's do that. Where do we start?
Let's start in source/HIR. That's where we build the HIR from, or ZJIT/source/
ZJIT source. Horse says, I can't wait to wrap around and build an AJIT. I agree, yes.
Are we wrapping around, or are we continuing to a different alphabet?
No, we should wrap around. Like
AJIT.
How are you going to type that? Then you'd have to like type out alpha. It's too many characters.
I mean, you're on a Mac. You can do option A.
Yeah, but I like a JIT.
A JIT.
A JIT.
I work on a JIT.
I work on a JIT, yes.
I had a friend who used to work at a firm, and people would ask where she worked, and she'd say, I work at a firm.
Oh my gosh.
And that endless source of confusion.
Affirm. My in-laws, they all use a chat app. It's like WhatsApp, but it's called Line, Line, and I think it's so confusing because it's like, okay, I'll text you online. Like, okay.
Anytime someone says online, I'm reminded of the movie The Internship, where they keep saying on the line.
On the line.
And the teenager is like, it's online. So every time now I just say I'm on the line.
I'm on the line. Okay, HIR, right? We're doing HIR.
Yes.
Okay.
This is a huge file. Most of it is tests. That the tests are all at the bottom. So I think the thing you're looking for is ISEQ to HIR.
ISEQ lambda JIT.
ISEQ.
Lambda JIT with optimized functional features. Yes, I like that. Lambda JIT.
We will have to do probably some closure conversion or something at some point.
Okay, what are we? I got distracted. ISEQ
to HIR.
ISEQ to HIR. Okay, so this is the main routine that takes YARV instructions, converts them into HIR, and then yeah, that's what we got to do too.
Yes.
Okay. So let's find a place to do that with this giant font. Okay, so this is interesting. These are like the YARV instructions that we're converting, yeah?
Yes.
Okay.
Every one of these that we support has an entry, and it all the stuff where you see stack pop and stack push is all happening on a virtual stack.
Right. Because this is our, like, ZJIT. It's French-Canadian, yes. This is all of this is for like eliminating the stack moves or the stack operations. We're operating on a virtual stack, and that's how we're going to calculate the CFG basically.
Right. We're going to unroll it in the best case, and in some cases, we might have some issue like the EP escape, and then we have to write to the real frame. But for this, we don't.
Okay. So we got get class variable. I don't remember what get class variable takes. Let's look at should we take a look at the YARV instruction?
Should we side by side it with instance.def?
I'd love to, but this font is too big.
We could put it below. We can look at 2 lines each.
Okay. So insns.def get class variable. So this is where the YARV instruction is defined. And we take it, I guess we have 2 parameters, an ID and an inline cache, it looks like. ID is going to be the name of the class variable. Inline cache, we don't care about the inline cache, do we?
When you say parameters, you mean inline in the bytecode, right?
Correct, yes. Parameters, not stack values.
Right.
Yeah.
We don't care about the inline cache. I think what we're doing right now is default ignore the inline cache, and then if we add one later, great, but if we don't, that's also fine.
Okay. And I guess we don't pop anything off the stack. These are the values that we would pop off the stack, and we push a value on the stack. That's all we do. So it looks like when we do, what this says to me is get class variable only ever operates on self.
That seems right.
Yeah, because like if you look at this, when we read it, there's no you can't be like other object. Like there's no way to give a receiver to @foo.
Right. You have to call it class variable get or something.
Yeah. So okay, so what do we need to? If that's the case, do we even need to push any? Like I guess we just care about the ID. This.
Yeah, I think we have to. Um, well, so here's what I'm thinking. What we do for instance variables is so we actually, can we pull that up?
Yeah,
Uh,
it's probably going to be exactly the same as get instance variable. Yeah.
yeah.
Oh
So
yeah.
we get the ID out from the bytecode stream. That's what the get arg is. It reads from the bytecode stream, and then we say there's this new HIR instruction that's get ibar. That's all get where ibar is instance variable. We can
Right
probably
here.
do something. Yeah, we
Yeah.
can do the same thing for we can have a self and an ID and call it get class var.
Let's just copy paste this. I think it's the same.
Great.
Okay, so this is the ID. What is snapshot? Do we need this?
That's a great question. Can a class variable lookup have any side effects at all?
What do you mean?
Can it cause a garbage collection? Can it write somewhere? Can it?
Ugh.
Yeah.
I would get so I don't know, but I would guess yes because probably you can do like a trace point or something on a read. I guess.
Trace points, let's ignore because I think that's a global thing that we can say if you're doing trace points, you get no code. Sorry.
Okay, let's check out get class variable blah 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 blah.
But to answer your question, the snapshot is the thing that copies the virtual stack, like that says, oh, v1 and v2 are on this stack here, and this local x is v5, and then we use that later to transform if we have a either an error or we have a condition we can't handle because we've optimized for one condition. We use that mapping to go back into the interpreter.
So I'm looking at the implementation for get class variable, and I hate this, and I assume that like hopefully chat will dislike it as well. Apparently, we use like the same infrastructure for instance variables as we do for class variables. Like they're stored in the same table. You can do RB. We just use RB ivar lookup on it. So there you go,
Well,
everybody. Does the same thing.
the class has ibars, I guess. That makes
Yeah,
sure.
sure.
Why not?
Sure. Seems fine. Um, but I guess if that's the case, then we need to do the same thing that IVs would do, yeah? So.
Well, we don't need to look at that. That's the cache stuff, though. So,
No, no, no. I'm saying with regard to like the snapshot. Like it has the same behavior, so it must do the same thing that a get instance variable would do.
oh, sure, then yes.
So, but here, let's do. Do we want to? We
Let's make a new one.
Okay, okay.
Well, actually, if you're going to say we could have a get class or a type of instruction and then use get ibar.
No, let's make a new one. Let's just make a new one. It's easiest.
Okay. We'll come back to this. That's an interesting. I don't know the semantics well enough, but that's an interesting approach.
Let's just make a new one. Class. What do we call it? Get class. Var. Yeah. Uppercase V. Does it matter? Do you care? V.
I
It's two
probably will
words.
develop opinions at some point.
Okay. All right. This seems good. So we've got a push. So we're pushing this on, but we need to go actually implement that get class var. So let's find snapshot. Actually, let's do get.
Let's find get ivar.
Like get.
Capital
ivar.
V
There
or
we go.
lowercase v. Okay. So go to the top and just search down for it. There's like a bunch of places we're gonna have to replace.
Get class ivar. Oh no, we're gonna have to
I think
do
you
this a
call it
lot.
get class var.
Oh
There's
god.
only like 6 places. It's okay.
Get class var.
So right now we're editing the printer,
Okay.
but there's other places too, like different properties of the instruction.
Oh goodness.
It's okay. We're gonna. Why don't we just replace ivar with class? Do a find and replace. Use your vim foo.
I did. I just did. I did.
Well,
We did it.
almost. We need
Well,
to get.
Wait, what? No, I
You-
did it.
it's-
Ah. Oh,
no.
okay. Okay. Thank you. And then this one's going to be get class.
So this is the type
var.
information that Aaron. Nope.
No.
Get class var.
Oh my gosh. Oh my gosh.
This is the type inference that Aaron was talking about.
This is. We should just have. We should just
Same
have
thing
an
here.
LLM do this. And INSN get class var.
Nice.
What the hell is this stuff?
So this is for dead code elimination. We track all of the dependencies that it's val, not var, I think. A little bit there. All of the dependencies that an instruction has that are other instructions, we want to make sure that if we have this thing that's basically garbage collection of the graph. So if one instruction is never used,
we just
want to keep it around.
Yep.
Yeah.
Why would you write dead code?
Most people don't intend to, but they end up just having a case that's never used, and it might get folded away by the compiler. And if that's in an if or something like that, that code will just linger until we manually delete it. We keep all of your code by default, but if it's not reachable, or it's or actually a better example is these constants. If you do 1 + 2, the Ruby compiler can't turn that into 3 because you could redefine integer plus. But if we speculate that nobody has redefined integer plus, we can fold that into 3.
And then delete the 1 plus.
And the plus are all useless, and then they can get deleted.
Gotcha. Okay. So that's a case where you end up with dead code, but it's by way of an optimizing compiler.
Yes.
Okay. All right. I think. Oh goodness.
That's okay. That's okay. We might have. I might get an angry mail about code gen, but I think we can try it.
Make mini Ruby. Oh goodness. No. Variant.
Oh, did we not?
No variant. Get class.
I guess we didn't define it.
I thought I did. Okay. Let's go find.
Get ivar.
Get ivar. Ah, yeah. Okay. Great job, Aaron. Get class var. There we go. All the same stuff. Make mini Ruby. Hey, wow, great. Okay. So it compiled. Can we dump HIR for this?
Yes, just call self.foo twice.
Okay. Do 3 times just in case.
So can you? It's behind us. There we go. Let's dump the HIR. We're not going to be able to. We don't have a backend for
HIR. Yeah.
Yeah. Nice.
Wait, that worked? That's it?
So that doesn't. We end up bailing. If you add ZJIT debug, it'll tell you I don't know how to compile get class var. So right now it's like we got that far, but we didn't actually.
We didn't do anything.
We didn't do anything.
Okay.
So it'll just be an interpreter function for now.
Okay.
But we can do that. I think if you want to spend 5 minutes fighting with this, I think we could do it.
Do what? Implement it?
Yeah.
Yes, that's why we're on this stream. Yes.
I don't know.
All right, let's do it. Let's find where does get ivar get lowered? Like how do we implement this? Where do we find it?
That's in source code gen, which takes the HIR and turns it into LIR.
ZJIT source code gen. Okay.
And this has this big. Yeah.
Oh goodness. All right. This is so it has basically a big switch statement that's like we're gonna convert all the stuff into other stuff.
Yes.
Get class var. Okay.
A lot of the time, a ZJIT HIR instruction gets turned into many LIR instructions.
Should I call this a CVAR?
You can do whatever you like.
I'm gonna call it a CVAR because I think that's what we use throughout the rest of the CRuby code base. I don't like it. It's just consistent with the other stuff.
We have made some naming decisions that are not consistent with CRuby for the purpose of making the compiler slightly more readable.
Okay, emit an uncached class variable lookup. We're just gonna do exactly the same thing. I don't like.
That sounds great.
Let's just emit. We're gonna emit. So, all right, chat. What we're doing here is we're emitting a C call. So what we're gonna do is we're gonna have the JIT machine code just call into a C function. Yeah.
So this is an LAR instruction that represents a call to a C function that takes in. So this is a nice macro that Alan made, where the asm call thing takes in the assembler, and then the name of the function, and the macro splits it into the string, so it can use that for a comment. It turns RB ivar. We should change that to cvar.
Yeah, we'll fix that.
RB cvar get into a string for the comment, and then it also gets the function pointer for it, and it passes the function two parameters: the receiver and the Is the receiver self?
Yeah.
Oh, great. Okay.
Yeah.
And then the ID, which is from the bytecode.
Let's take a look. So one thing I want to look at is in like this VM class variable thingy, if I remember, it falls all the way down to this RB ivar lookup.
If the cache is full, right?
If the cache is full, yes.
So if we don't have a cache, we should.
Otherwise, we have to do all this jazz.
So let's look at the get cvar base.
Oh gosh, this is a lot of stuff. I think we should make a function that just does this.
Wait a minute. Hold on. Why is this? What is this? What is this?
Don't look. No. Don't look too closely. Please.
Well, how does it differ from RB cvar get then?
There is no RB cvar get.
Are you sure?
No, I'm not sure. It looks like there is. Sick. Never mind. Let's do this.
This is the thing that I don't understand how it works.
What? C tags?
Like, no, I understand this. C tags is magic. I don't know how it works.
Let's just do this. RB cvar get. Cvar get. That's it, right? Receiver is the class? Yeah.
Well,
sure.
the receiver is not the class there. That's an instance.
It's
no, it is the class.
It's a class, yeah. Yes.
But can you call it from? Can you do add foo from an instance?
An instance? I think you can. Yes.
Let's see if that breaks. Let's see if it breaks.
Okay, so this should work. I mean, this should work, yeah.
I'm reloading maybe. We just have to add it to the bindgen.
Bindgen, yeah.
So we keep a list of allowed C functions that the Rust code can look at. That's in main. And if we can put it next to ivar get.
cvar get.
Yeah.
And I don't want to run bindgen because
why not?
Because it doesn't. Last time I tried,
it didn't work.
Yeah, I don't want to do it.
All right, just edit it manually. Whatever.
ZJIT source bind. No, it's
I think it's in source cruby _ bindings.
Bindings Inc.
Yeah.
Okay, and then there we go. Yep.
Yeah.
We're just gonna cvar get into there because it's the same.
Don't do this at home.
Yeah, this is dangerous. Please don't do this. Hey, okay. So now let's try running with HIR.
Add ZJIT debug. We still don't know if it.
Okay, what do I do? Dash
ZJIT debug after that.
Like this? Yeah. Okay.
Okay, it didn't complain, so I think we actually admitted and then ran code. Do you want to print it out?
Yes, we should. Good point. See if it actually prints out 1, 2, 3.
Yeah, if it starts printing garbage, then we know we messed up. Well.
Oh, well, I should fix the file name. Boo Boo is asking why is it called Mini Ruby? That's a great question. When you build Ruby, there's actually 2 Rubies that get built. There's the Bootstrap Ruby, which is a smaller, like a very small version of Ruby, and that's what we call Mini Ruby. And the full version of Ruby is just called Ruby. So typically when I'm working on Ruby itself, if I only need to test out language features or JIT stuff, I just use Mini Ruby because it's faster to compile that. You don't need to compile everything.
Like, it doesn't work with Ruby gems or anything like that, right?
Right. Hey, it printed it.
That's pretty good.
Okay.
I want to try. Let's be dangerous. Can we add another method that reads it from
the instance? Yeah. Let's do so we're gonna foo equals foo.new, and then we'll do too many foos in here. I'm gonna run this with the interpreter first because I don't actually know if it works.
Okay.
It should.
This is gonna error because
What?
it's called lol.
Oh right. Thank you. Come on, pair programmer.
I'm trying my best.
Here we go. Okay, so that works. So let's try running it with ZJIT enabled.
Hell yeah, let's go. Yeah.
Okay, all right. So now what?
I don't know. I'm curious what the error is. I think that means that we need to do the semantics are slightly more complicated, and we would need to do something like looking up the class of the self.
Sure.
Oh
wow, goodness.
Big. Okay, that just says it's not a type.
It's not the right thing. Yes, it's not the right. It wants a class, and it didn't get a class. I think we have to do like actually
class
something. I don't know. Well, I guess let's look at what the instruction actually does.
Yeah.
Let's see. Get class
variable.
Always a good
strategy is figure out what the code should do before doing it.
Okay, so we do get class variable, and then what does this thing do? It's like, oh, we got to get the cref class.
What's the cref?
I think it's the class ref. Like, I think. See.
Oh, it's the last entry in the class nesting.
Maybe, yes. I don't remember. cref? No, this is not good. We don't want to read out of this.
Well, what if we go down to the uncached case?
Yeah, let's see.
Does it also use cref? It does use cref.
Sure does. Wait, oh, look at this. It's like VM get. We use the cref to determine the cvar base, I guess. So this is figuring out what class, like who has the thing.
Oh no.
Yeah, this is gonna be non-trivial.
So okay. It's a linked list, and we're skipping the singletons and the eval. Oh boy.
Yeah, this is a bummer. We don't like this.
And it turns out we actually do. It can throw an exception.
Yes. We're not doing this today. This isn't happening on the stream. No.
Let's probably not do this for a while. I mean, this is all doable, but it's not common and probably not expensive.
Oh boy. All right, we're going to end since we only have like 1 minute left. Let's end here. We got something working. It's not exactly what we wanted. It crashes. But it works in the happy path, yeah? Where we've carefully crafted the code to work. Okay, I'm gonna bring you back up here. There. Hello.
Hello.
You're back.
Good to be in Seattle.
Oh yeah. Yes. Welcome to Seattle. Someone is saying it should be
home of Tim Hortons coffee.
No, we're home to Starbucks. It's the local coffee. I like to support the local coffee. Okay. Thank you for joining today.
Thanks for having me.
Oh, that's right. Yes, you are also the latest Ruby core committer.
I'm the latest? Oh wow.
I think you are. I think you're the most recent. So yeah.
Cool.
That's great.
Thanks for having.
Yes. Anyway, thank you for coming on. Thank you for walking all of us the live stream through HIR and ZJIT and all that jazz. I'm gonna do some outro stuff, so I'm going to take you off now. Bye, Max. Okay, Keynote. Back to Keynote. Let's see. Yeah. So, oh goodness. I don't think anybody can hear this, but apparently this keynote has audio. Yes, I'm gonna get rid of that because I don't like it. All right. Anyway, thank you all for coming to the stream today. Like I was saying, if you have any suggestions for topics, like please let me know. Let me know in the comments, or let me know like email or anything. I think next month I want to do some stuff. I want to add a new syntax is what I'd like to do. I'm thinking about doing that. But if you have any ideas for topics or any suggestions, please let me know. Thank you all. It was really fun to do a live stream again. I will try to do this more often. Have a good Friday, everybody. Bye.